Okay. So what happens to the electrons if you have two charged spheres and then you bring them into contact, then separate them again? What happens to the electrons in the process?
I think the electrons will be transferred to the sphere.
From a sphere which has to a sphere which has from a sphere which has
Protons.
from a sphere which has excess amount of electrons to the one which has less electrons. Do you agree?
Yes, sir.
Okay. And then after separation, the amount of charges that are contained on both spheres, is it different or is it the same?
Please repeat that, sir.
The number of electrons that are contained on the two spheres after separation, is it different or is it the same? Is it different or is it the same?
I think it's different.
No. No. When you separate the two spheres, they then contain the same charge because electrons will flow from the sphere which has less electrons to the one which has from the sphere which has more electrons to the one which has less, until the same sphere has equal number of electrons. Then when you separate the two will have the same charge. Are we in the same page?
Yes, sir.
Okay, so that is what we're gonna be talking about in electrostatics. I'm still looking for. Okay, where was I? Still looking for last week's portion of work. Okay. And how was maths yesterday?
It was fine, sir.
Okay. Right. The topics it was what's that topic?
Simplifying algebraic equations.
Oh, okay. Okay, no, that's good. Okay. I think I should just open a new exam. It's fine. Okay. The other question is what is the formula of calculating the new charge on each sphere after contact?
Is it Q final minus Q initial?
No, that is when you're calculating the amount of charge that has been transferred. It's the other formula.
Q nu is equals to Q1 plus Q2 divided by 2.
Aha, that's it. So the reason why you add the electrons on both is because when you combine the two becomes one. And then after separation, each will contain the same charge. You understand?
Yes, sir.
Okay. We did, I just want to check. We did this problem. I just want to do a few problems, especially on electricity. Okay, so before we move on, what is current?
It's the flow of charged particles such as electrons or ions moving through electrical conductor or space.
Okay, yeah, that's true. Okay, and what is the resistance? Resistance inside the conductor.
The opposition to the flow of current in an electrical circuit.
Yes, it is the opposition. Okay, fine. Now I want to share the screen so we can continue. This is what we have. Okay, that's good. Now, a battery consisting of 4 identical cells of unknown EMF is connected to 3 resistors, a bulb and a bulb. Oh, you can't see. Okay. Can you see now?
No, sir.
Okay, let me stop sharing and share again. Okay. Can you see?
Yes, sir.
Okay, now that's good. A battery consisting of 4 identical cells of unknown EMF is connected to 3 resistors and a bulb as shown in the circuit. The connecting wires and the battery have negligible resistance. Now define the potential difference. What is the potential difference?
The ends of a conductor is equal to the energy transferred from electrical to the other forms of energy.
Okay. In words, you can say it is the energy. It is the energy transferred during the movement of charges inside the conductor. Or energy used to move charges. So the potential difference is equals to W, work done to move charges, work done per charge, per unit charge. So 6.1 work done per unit charge to move charges inside the conductor. Okay. Which voltmeter will provide a non-zero reading when both switches S1 and S2 are opened? which voltmeter will provide a non-zero reading? There's two voltmeter. There's voltmeter V1 and voltmeter V2, as you can see on the screen. V2 and V1. Which one will produce a non-zero reading? V1 or V2?
I think it's V1.
V1 will give you a non-zero reading. Okay. What is the EMF of the battery?
The potential difference across the battery in the open circuit.
In an open circuit. When S1 and S2 are opened, is this not an open circuit?
Yes, sir.
Is this not an open circuit? When S2 and S1 are open, isn't that what we call an open circuit? Okay, so if it's an open circuit, where are we going to read the EMF? Is it V1 or V2? Kumis, the EMF of the battery, where are we going to read it? On V1 or V2?
It is V2.
It is V2 because it is the potential difference across the battery. So that is the only non-zero potential difference that we're going to read, because V1 will be zero because there won't be any current flowing through the circuit when S1 and S2 are open. Do you agree with me?
Yes, sir.
So if there's no current flowing through the circuit, it means that there won't be energy consumed by your resistors, meaning your resistors won't use any voltage. There won't be any work done because the circuit is open. There's no flow. Okay. The answer is, let's see, the answer is V2. Okay. V2 is the answer. Now, switch S1 is now closed while S2 remains open. Okay. The ammeter reads 2A. Calculate the reading of voltmeter V2. So how do we go about this one, Kumisa?
I think we're going to use Ohm's law.
Exactly. Electricity problems are Ohm's law problems. Okay. So they want us to calculate, what is it, voltage? Yes.
Yes, sir.
So according to Ohm's law, V equals
I times R.
IR. Okay, perfect. The value of I will be
2A.
2A times the resistance is going to be, what will be the resistance? What will be the resistance? What is the total resistance of the circuit? I think that's what.
12, sir.
12. Okay, I'm gonna come and I just wanna put the charger of the battery. Yes. So I'm gonna try to show all the calculations. You are right, you're correct. So it's going to be 12, but I just want to write it properly. 4 plus 6 plus 2 equals 12. Sharp. No. What is the answer? 24 volts, right? So that 24 volts, what is it? It is the EMF of the battery. You agree?
Yes, sir.
That is what the battery is supplying. You agree? It is supplying it to your 4 ohm and to your 6 ohm and also to your 2 ohm resistor. All in total, they give us that 24 volts. Okay, that's fine. And then both S1 and S2 are now closed. The ammeter reads 2A. The first question is calculate the voltmeter reading V1. Okay, so we have 6.4.1. So how do we go about solving that one?
V is equals to I times R.
V equals IR. Perfect. Okay. Now your I will be
3A.
3A. Okay, it will be a 3A. Let me just write it as 3. Okay, this will be 3 times what will be the resistance? What will be the resistance that we're gonna use? What will be the resistance, Kumis?
Are we still gonna use 12?
12. You said 12. No, we're not gonna use 12 anymore. Remember, once switch S2 is closed, now we have a parallel connection. We have a
6.
parallel connection. Do you see?
Yes, sir.
However, we have an unknown resistor right here. So if
So
we
that's
have,
the bulb. Isn't that bulb? Isn't that a bulb?
yeah, that's a bulb. That's a bulb. So we have an unknown resistance. Remember, a light bulb is a resistor. Do you agree?
Yes, sir.
Yes. Now, unfortunately, the resistance across it is unknown. The resistance across it is unknown. So now how do we calculate the reading of V1? Okay. Do you agree that the portion of 24 volts is going to be used by the 4 ohm? You
Yes, sir.
agree?
Yes, sir.
Okay, so how much will 4 ohm resistor use? How much our 4 ohm resistor, how much will it use?
6 ohms.
So it will use 3, okay, 3 times, you said, no, it won't use 6 ohms, it will use 4 ohms. It will have a 4 ohm resistor. But do you agree that the current of 3 ohms is actually flowing through the 4 ohm resistor? Do you agree?
Yes, sir.
So if it's flowing through the 4 ohm resistor, the amount of voltage that is going to be used will be 3 times 4. So we're going to get 12 volts. And then if 3 amperes of current is flowing through 2 ohms, the voltage used will be 3 times 2. You agree?
Yes, sir.
That will be 6 volts. Okay. So in order for us to find the amount of voltage used by the parallel setup, because the parallel setup at the end of the day must be treated as one. You remember from the last lesson that we did, we have been doing a lot of calculations of the equivalent resistance. You remember?
Yes, sir.
And then after calculating the equivalent resistance, we go and reconstruct our circuit and make the parallel connection one resistor. You still remember?
Yes, sir.
Okay. Now our parallel connection will have the following. Do you agree that the total EMF is what is it? It's 24.
Yes, sir.
So what will be the potential difference across the parallel connection? What will be the potential difference across the parallel connection? If we know that the 4 ohm resistor consumed 12 and the 2 ohm resistor consumed 6, and the total is 24. So how can we calculate the voltage on the parallel connection?
The RT is equals to R1 plus R2. You're
Okay.
1 over RT.
Yeah, that is true. What you just said is true. That is true, but we have an unknown resistor. So do you agree that the voltage on the parallel connection is given by the total EMF minus the voltage on the 4 ohm resistor minus the voltage on the 2 ohm resistor? Do you agree?
Yes, sir.
Because all the energy, all the voltage that is supplied by the battery is going to be used by all the resistors, including the resistance in parallel. So the total that we got was 24. Then 24 minus 12 minus 6. So 24 minus 12 minus 6 will give us, let's see, I think it's 6. Isn't it 6?
Yes, sir.
Yeah, 6 volts. Perfect. Now, given that we know how much our parallel connection will consume, which is 6 volts, how can we calculate the resistance of an unknown bulb? Because the question said calculate V1. We have already calculated V1, right? So we are done with the previous question. So the next question says, this is 6.4.2. It says, let's see. Calculate the resistance of the bulb. Says calculate the resistance of the bulb. Okay. So you have said to me that the resistance across the parallel connection is given by 1 over R1 plus 1 over R2. I agree with you. Okay, do we have the value of RT?
No, sir.
Can we find it?
Yes, sir, I think so.
How can we find it?
When you use R is equals to V divided by I.
R is equal to V over I. Okay, so what will be our V?
6.
6. And our I?
3.
Yeah, you're right. It's 3 because because that 6 volts, we are assuming that our parallel connection can be summarized into just one resistor. So we just assume that there will be three amperes of current flowing through the equivalent resistor that we are talking about. And that equivalent resistor will consume 6 volts, which we have calculated. You agree, right?
Yes, sir.
Okay, so our answer will be 2A. So, not 2A, sorry, 2 ohms, yes. 2 ohms, but the ohms, the resistance that we have calculated, it is the what? The total resistance. You agree?
Yes, sir.
Okay. Now, 1 over 2, which is the total, is given by 1 over, do we have the value of R1? We have the value of R1.
Yes, a 2.
No. Remember, the value of R1 is this resistance, and R2 is this one. And then when you, R total is what you calculated, which is 2. This is the R total of the parallel connection. You agree?
Yes, sir.
So R1 will be 6. Then what will be the value of R2? Let's go back. The value of R2
No, it's 4.
why is it 4?
Oh, and then it's 2, sir.
We are only dealing with the parallel connection. Okay, Do you agree?
Yes.
Do you agree that in this equation, what we have calculated here, it is the R total, which we have replaced 1 over 2 equals 1 over 6 plus R2 is the unknown resistor of the light of the light bulb. This one, it is not given. That's the one that we are looking for. I can hear, I think you're a bit confused. Okay. Let me re-explain. Okay. The R total, this is the equivalent resistance of the parallel connection. Now, R1, it is the resistance of one of the resistors in parallel. And R2 is also one of the resistors in the parallel setup. Do you agree?
Yes, sir.
Okay. Now, we have already calculated R total, which turned out to be 2 ohms. Turned out to be 2 ohms. So I just took the R total, which is 2 ohms, and I replaced it. And fortunately, we only had R1, or you can use either. You can assume it as R1 or assume it as R2, either way. But you will have one unknown resistor, and that's what we are trying to calculate. Do you see?
Yes, sir.
Okay. Now from here we have 0.5 equals 1 over 6 plus 1 over R. 1 over R. So 1 over 6 will give you how much? Let's see. So 1 over R will give you 0.5 minus 1 over 6. So how much do you get from that? Let's see. 0.5 minus 1 over 6.
0.3 recurring.
Okay, 0.333. So what is the value of R? What is the value of R in this case? The value of R will be 1 over that whole thing. So it will be 0.3333. So how much are you getting? One over 33333. Okay, I'm getting 3. The unit is ohms. Okay, now let's go to the next one. The next one says, what is the energy transferred to the bulb in 1 minute? Which formula comes to your mind when we talk about energy? When we talk about energy dissipated by a resistor, which formula comes to your mind?
The I
Which
is equals
formula?
to Q over change of time.
Okay, you said I equals Q over change in time. Okay. So do we have the value of I?
Yes, sir.
Okay, so the value of I will be, what will be the value of I?
3.
Remember, the value of I won't be 3. The reason why it won't be 3, your 3 ohm will be divided. When the 3 ohm resistance reaches this point, it will be divided. Do you remember that the parallel connection divides the current? Do you agree?
Yes, sir.
Okay, so if it divides the current, what will be the current going through the bulb? Again, we're gonna use Ohm's law. So the current going through the bulb will be given by voltage divided by R. Now, what is the voltage across the bulb? What is the voltage across the bulb?
It's 6.
It is 6 because we are talking about the voltage of V1. I agree with you. V1. Okay, so it is 6. So if it's 6, we have 6 divided by what is the resistance across the 3 ohm resistor? It is 3. I don't know why I even said what I said, but it's fine. Now, 6 divided by 3 will give us
2 amps.
2 amperes. Okay, now we have the value of I going through the 3 ohm resistor or going through the bulb. So we know that 2 equals Q over change in time. Our change in time is 1 minute, which is
60 seconds.
okay. So I'm gonna write 1 times 60 seconds. So the value of Q will be given by, how do we calculate the value of Q? So how do we go about this one? Okay, cross multiplication. I don't know how, cross multiplication. So Q times 1 gave me Q. 2 times 60 gave me 120. 120 coulombs. Ne? But we are not looking for the charge that has been transferred. We are looking for energy. Do you know any formula that relates energy and Q? Please. Okay. What is the definition of potential difference? A potential difference.
The energy used to move the charges per unit of charge.
Okay. So do you agree that the formula of the potential difference is V equals W divided by what? You agree with this formula? If you go to your formula sheet, you will get it like this. Do you agree?
Yes, sir.
Okay. Now they are looking for W, not V. So your W will be equals to what is the formula?
V times Q.
V times Q. Okay. Do we have the value of V?
Yes, sir.
It is
6.
6. And then do we have the value of Q? Yes. 120. So this will give us 6 times 120. Gave us 120. And the units? It will be in joules. Okay, that's perfect. That's perfect. That's good. I want to do a problem in electrostatics quickly. If we don't finish, if we finish it, it's fine. If we don't, that's also fine. Okay. Okay, Kumisa, quick question. Does proton move?
No, sir.
Does electrons move?
Yes, sir.
Okay, you are right. I just wanted to see where we are. Okay, now what happens after separation? When two spheres that were in contact are separated. Can you describe the process? What happens to the charges? Can you describe the process? What happens after contact?
Conservation
In
of
the two
charge.
sphere? That will be
Conservation of charge.
that is true. The conservation of charge. How can you define the term conservation of charge?
Charges that cannot be created or destroyed. It can only be transferred from one object to another.
It transferred from one. Do you raise your hand in class?
Yes, sir.
At school? Okay. Have they ever asked you about this one, the conservation of charge?
Yes, sir.
Okay, and you got it right.
Yes, sir.
Okay, perfect. Because there's actually two definitions. You know the other one also was. The other one, it says in an isolated system, the amount of charges are conserved, and that's it. The number of charge, the amount of charges is conserved in an isolated system. But the one that you gave is also very nice. Okay. Determine the number of access electrons on sphere A. Sphere A, how many number of electrons do we have that are in access? What is the formula? Calculating the access number. What is charge quantization?
When all charges are multiples of the smallest charge.
Okay. And the amount is 1.6 times 10 to the power of minus 19 coulombs. Not all charges, all charged objects. If you say charges, yeah, you can say so. I think you can say so. I don't think they will penalize you. But the proper definition is to say charged objects, but it's fine. Okay. In which direction will electron flow when the two spheres are in contact? Is it from A to B or from B to A?
I think
Komis,
it's from A to P.
that's correct. Why? Because A has a lot of electrons. A to B. A to B. Now state the principle of conservation of charge. We have already done that one. Calculate the new charge on sphere A. Calculate the new charge A. Oh, okay. No, they said the spheres were allowed to touch and then separated. Ne? Calculate the new charge on sphere A. How do we go about it? How do we go about it? The new charge. What is the formula?
Q new is equals to Q1 plus Q2 divided by 2.
That's perfect. That's correct. So we have minus 4 microcoulombs plus how much? Plus 8 microcoulombs divided by 2. So how much do we have? 8 minus 4. 4. 4 divided by 2. That's 2. So it's 2 microcoulombs. Okay. What is the charge? What is the new charge on A? Miss.
I think it's 2.
What is the new charge? Yeah, it is two microcoulombs. And so what is the charge on B? What is the new charge on B? What is the new charge on B?
Is it 8, sir?
It is not 8. I told you after separation, the two charged spheres will contain the same charge. Therefore, if sphere A has 2 microcoulombs, it means sphere B will have how much?
2 microcoulombs.
Exactly. Exactly. After contact, the two spheres will have the same charge. Let me repeat it once again. After contact, the two spheres will have the same charge. Now, 5.2.5, we're going to do it in the next segment because I can see we are running out of time. So I will see you on today's Tuesday. So we're going to have another lesson on Thursday. So I'll see you on Thursday. All right.
Sure.
Live. Hey. Maybe